Students that will be competitive in the global economy must be provided higher levels of learning. This means that the standards identified in the Next Generation Science Standards and the classroom instruction must change to meet those demands. As mentioned at the beginning of this teacher video series, the Next Generation Science Standards have 3 parts. The first component of the standards is the practices, which describe behaviors that scientists engage in as they investigate and build models and theories about the natural world. The goal is to encourage self-directed learning, where your students must think carefully, critically, and creatively. The second component is the cross-cutting concepts, which is a way of linking together the different domains of science. They include patterns, similarity, and diversity, cause and effect, scale, proportion, and quantity, system and system models, to name a few. The standards emphasizes students' need to show how these concepts are interrelated from the various science fields so that they develop a coherent and scientifically based view of the world. As you can see, the teachers in this video are referring to concepts previously learned in other classes or grades to support these cross-cutting concepts. The third component is the disciplinary core ideas, which have the power to focus K-12 science curriculum, instruction, and assessments on the most important aspects of science. The core ideas provide broad importance across multiple sciences or engineering disciplines, provide a key tool for understanding or investigating more complex ideas and problems, relate to the interests and life experiences of students, or be connected to societal or personal concerns, are teachable and learnable over multiple grades. Since better educated equals better employed students, the educational system must provide increasing access to high-level science instruction to all of our students. Let's talk about some key instructional changes you will see with the Next Generation Science Standards. Focus on the integration of rigorous content and application reflected in how science is practiced in the real world. Encourage the integration with multiple core concepts throughout each year. Build standards from grade band to grade band to allow for that dynamic process of increasing science knowledge throughout the K-12 continuum. Involve deeper understanding and application of content rather than a fact-driven instruction. Raise engineering design to the same level as scientific inquiry and science classroom instruction at all levels. Let's hear from a few more teachers in our Teachers Corner segment to hear some tips on how they grew their expertise and skill set around NGSS.
I grew my understanding of the NGSS through working with Cal State Fullerton, as well as the Santa Ana Unified School District, to understand how we use a driving question, as well as the 5 E's of understanding, to get the students ready for the Next Generation Science Standards using cross-cutting standards as well.
The experience in itself is much more memorable than any textbook could ever draw. Working as a team and as a group and following procedures, that's just important in general, being able to get the results that you want.